Hello grade 12, 10, hello grade 10, back again for the PAT. So I've added two other group boxes here. I've put a label there and an edit box there and a button and a rich edit there. Call that already out one. Then I use another label, another edit and a button, and that's already out two. So I gave my rich edit names. Remember the rich edit has a lines property where you can go and get rid of the lines in the rich edit. You also need to make sure that your rich edit has scroll bars. So go to the scroll bars property and choose both. So make sure you do that. In this edit box here, you can make it large or small, you can decide, but you must have names for all your components and must have appropriate captions, and over there you go and put appropriate caption in that group boxes as well. We'll talk about the scramble alphabet later, but now we're going to go to the actual encryption of a string. If you look at the Word document, this one, you'll see that underneath the picture there we have data structures. So we've done the text file. We are going to now go and do this button called ciphertext. So there's a button called ciphertext and it's got these variables. So we'll use those variables because they're there. S plain text, C letter, I pause, and S ciphertext. So let's go and make variables in this button click event here. You've got to give this button a name. I'm going to make the variables here. C letter, colon, char data type. What else was there? There was IPOS and S ciphertext. So S IPOS, because we're going to go find the position of a character, and that's an integer data type. And S ciphertext is going to be our resulting string that we display in the rich edit. So what do? We're going to go first get our input. The input is coming from EDT plain text, so we say S plain text equals EDT plain text dot text, colon equal right. So we've got our string. Now we're going to go through each character of the string. Just have a look at what S alpha looks like. See that? That's S alpha, the string 1 to 26. I haven't got all of the characters there. And here's the code, which is character 1 to 26, just like S alpha. It's also numbered with characters 1 to 26. If character number 1 is going to be replaced with character number 1 of S code. But what is S plain text? S plain text, let's say the person typed in the following: I space like dogs. Okay, so there's S plain text. Let's say they type that in. And those are characters as well. They're numbered from 1 to whatever the length of S plain text is. For instance, this sentence, I like dogs, has got 11 characters. Yes, spaces are characters as well. And we've got to keep the spaces inside when we have our S ciphertext. So what's going to happen is if you look for the I over there, we know that's going to be an X. Okay. Then the space must stay, and L, if we look for the L there, we know it must be replaced with a P. Capital P actually. And then another I, which will be an X again. And the K is going to be replaced with a Y. And the E is going to be replaced with an F. Then we'll have a space, and then the D must be replaced with an E. The O is going to be replaced with that's an L. No, it's not, it's a capital I, isn't it? Yep. The G will be replaced with an H. And the S will be replaced with Please S. Well, I haven't got S here, so I like a dog. Well, let's leave that one out, shall we? Because I basically haven't got all of the characters yet. So let's say that's our sentence. Alright, I like dog. Doesn't make sense, but we're going to use it. Right, so there is our S cipher text. After we have done the process in that button click event, and it's going to also have the same number of characters, so the spaces must stay. But you get the idea what we're going to do. So we're going to go through each character of S plain text and look for its character number in S alpha. So there's an I, capital I, but we've got to go and make S alpha equal to capitals, not so, because we cannot, it won't find it in if it's a small I, and we've got a capital I there, so we have a problem. So we're going to have to go and get another string. We can't change S alpha. S alpha is a constant. You can't say S alpha equals uppercase S alpha. No, you can't do that because it's a constant. So we're going to make another variable here and call it S ABC, and we say S ABC equals uppercase S alpha. We can do that. So now our ABCs is what we're going to refer to. It's exactly the same string. It's just basically just getting another. This is now called SABC. Okay. Right. So we have to do that because we put small letters in here, and we want them all uppercase. And guess what we're going to do? Our S plain text we're going to change to uppercase, so that we don't. So that we're comparing the same thing. It's no good if it's all lowercase or a mixture of uppercase and lowercase. So that's what's going to happen. S plain text is now going to be all uppercase, and SABC is all uppercase as well, which solves our problem. I wonder if I can. Yeah, for some reason we can't do that. So S alpha is going to be all uppercase. So we're not going to worry about the rest of the alphabet because we haven't got time or space. So we've SABC is now all S alpha in capitals. S plain text has been uppercase to have capitals. Okay, so now we can go and look for the character. Now we will find a capital I here, won't we? We will find a capital L. Yeah, we will. So we've got everything the same case, and now we can go ahead and go through each character of S plain text. How do we go through each character? Well, we did that before in our onActivate event. We went through each character of S alpha. So I'm going to say for K equals 1, 2. Now this K must be declared here. Okay, equals 1, 2 length of S plain text, which we converted to uppercase. See, we're going to do a begin and end now, because we're going to do more than one thing in our for loop. Before we only did one thing. Do you see the difference there? It was just one thing we were doing, but now we're going to do more than one thing. Now we're going to say, we're going to get the pos of S plain text character number, the pos of each character in our pos equals pos. Pos is our string handling function. Why? It's a function. It's on the right hand side of our assignment statement. So it's the position of this character inside our SABC. If you look at the spreadsheet, so we get the first character I. What's the position of this character in SABC? There it is. It's the number 9. So guess what? We're going to go and find number 9 character in S code and join that to our ciphertext. We're going to build this ciphertext up inside our string. It's all about building strings inside a loop. Sorry, not inside a string. We're building the string inside a loop. We get the position of each character. This is S plain text character number K. It's going to go from 1, 2, 3, 4. How many characters do we have? We have 10 characters. So the K is going to go from 1 to 10. In this example here, if we type in I like dog, we're going to go from 1 to 10. Length is going to be the number 10. Length is also a function. And for each character, we're going to see where's the position of that character inside our ABC, which we converted to uppercase. We converted S alpha to uppercase and stored it into a string. Right, so if we get IPOS, then we can go and build S ciphertext. Now, whenever we build a string inside a loop, we always have to initialize it to an empty string. Just like we initialize counters to naught, we always initialize our but before I do that, I'm going to use my C letter because that's declared there. I could do it without using it, but we're going to use it. We're going to say C letter is the letter that we're going to join. So C letter will be S code character number. In this case it's 9, but we're going to use character number IPOS. So remember, IPOS is getting which is the character number of this capital I in SABC. It's character number 9. So IPOS is 9. And so we're joining S ciphertext will be S ciphertext plus this character number 9. But I'm going to just call it C letter, will be character number 9. C letter equals S A B C character number IPOS. So we get the position of the character number in the ABC. There it is. And then we're going to use not ABC, S code. We want to use the corresponding character number in S code. We want S code character number IPOS. We want that character number. That's IPOS. Can you see it's corresponding? They're like parallel strings almost. Well, they are. They've got the same character number 11. Character number 11 in SABC must be replaced with character number 11 in S code. So we're going to get our character from S code. It's S code character number whatever IPOS is. And now we're going to go join that to S cipher text equals S cipher text. Join that to C letter. But here's an issue here. What about the spaces? Well, we're going to say if S plain text character number K, if it's not a space, if that is not a space, well, how do you do a space? Semicolon, space, semicolon. I mean inverted comma, sorry, not inverted, semicolon. Then we'll do these three things. We're only going to go and look for characters if that character number is not a space. Okay, so there's a space. See the difference between an empty string and a space. Right, so if the S plain text character number K, if it's not a space, then we can go. If it is a space, what are we going to do? Well, we have to have an else here. Else, begin and end. What are we going to do? We're going to say S ciphertext. We're going to join a space to our string that we're building plus a space. We don't have to worry about any other characters because we did our checking. Oh, we didn't do our checking, did we? We never checked. What if our S plain text has got numbers in and so on? Things that are not characters and not spaces. Well, we have to go and write code to make sure that has not happened. So let's do that. First of all, we've got to go and check if S plain text is empty. So this is our actual code to cipher and everything, and then we'll display it in the already out one.lines.add. Display S ciphertext there. We're going to go and check our input. We haven't checked our input, but we're going to do that now. We just quickly display this dot clear. we have to check our input over here. We have to say if s plain text is equal to nothing. See that? That's an empty string. Then we will show message and exit. Please enter a sentence, because there's nothing there. And then we'll exit, and we'll know that that will close this button click event. Don't forget you must name your button. But what if it is a if there's a number in it? For instance, if the person entered the number 9 here at the beginning. Okay, what if the person entered the number 9? So we can get rid of that now. If the person entered a number 9 or a hash or a percentage or anything that's not either a space or a letter of the alphabet, well, we have to go and check that. I'm going to use a while loop, so we can say while. What's going to happen is we'll have a Boolean flag, be valid, colon Boolean. We call them Boolean flags. We set our Boolean variable. You see, Boolean can be true or false, so it helps us to check things. We set it to, let's say we set it to true. Okay, we're assuming that the whole sentence is true, but we're going to check each character. So while be valid is true, we can carry on, but we also need to go, because we're using a while loop, not a for loop. Remember before we used a for loop going from 1 to the length of the string? Where did we do that? There we go, 1 to length, yeah. But we're not going to do that because we don't want the loop to just continue, because when you use a for loop, it's going to have everything here is going to happen that amount of times. But if you want the while loop, so for instance we want the loop to stop, we don't want the processor to do all the work of checking all these others. If it finds one, okay, there might be a number there, and there might be a number there, and there might be some funny character here, but if the first one is, we want to tell them straight away, stop. We don't want the processor to have to go and look through all the others. So we want the processor to stop. So we have this, we're going to use a counter while enum is less than length of s plain text. Okay, now this enum is going to be our little for loop counter thingy. So we're going to set it to 0, and we'll increment it inside the loop. Now that enum is going to increment until it is, if it's equal to the length, then it will stop. So if it starts at 0, it's less than the length, okay? Then it will be 1, then it will be 2, then it will be 3, 4, 5, say now there's 10, 6, 7, 8, 9. Okay, it increments, it's 9, checks there, okay, enum is still less than 10. So then it increments to 10, and then it does something. And then as soon as it's 10, it's going to stop. So the loop, that and, makes sure that this condition is now false. Remember we did two, what do we call them, truth tables? We had this, if this is true and that is true, they both have to be true. Both of these conditions must be true for this loop to continue. And this is how we can make sure the processor doesn't do more work than is necessary. So that will stop as soon as the one of the conditions become false. At the moment, be valid is true, enum is 0. So we increment enum, and then we say if not s plain text character number enum in the set of capital A to capital Z. Luckily we can do that. Oh, we haven't, have we changed everything to uppercase? No, we have not. We better go and make sure that this uppercase story happens here. No. We've got to change everything to uppercase because we're going to only use character A to Z, uppercase there, and then we can use the space here because we want this character. It says in the rules that if you look at the document over here, you have to do a range check. Okay, they use small letters there, but we're eliminating that because we've got S-plain text set to capital letters anyway. And it says only alphabet letters and spaces allowed, so that's what we are doing. We're making sure that there's only letters and spaces, because if it's not a letter or a space, then we can show, we're actually not going to show a message, we'll just say be valid equals false. Okay, that's it. That is our check. And then after the loop, this is end of the while loop. Eh? And by the way, you have to put comments for all of your lines. End while loop. End of while loop. This is what you must do for every single line to check if input is valid. So, if be valid is false, after this loop has gone through and done, and it's be valid equals false, then we can show message and exit. We don't show message and exit inside a loop. No, you cannot do that. You have to show message and exit afterwards. That is why we use a Boolean flag. We can't put let's show message and exit inside the loop. So we'll show message only characters and spaces allowed, something to that effect, and exit. So take note of that. You cannot put an exit inside a loop. So that is why we are going to have our Boolean flag set to false as soon as they find the wrong character. So in the case of this string over here, fortunately the processor, or this one, the processor won't have to go through all the others. It will just look at the first one and then the loop will stop. Why? Because then be valid will be false, so that condition is no longer true. In the and operator there, make sure that you have to have both of them true for this loop to continue going from one character to the next. See, I is going from character number 1. See, it's 0 and we increment as it's 1. Click on 1. If character number 1, not character number 1 in. Take note of the not operator. You cannot translate it straight to English. You can't say if that character number not in. It's very tempting to put the not there, but it doesn't work. You have to put a not and then open the brackets. Can you see I've got brackets around there? See the brackets? So that whole thing is being negated. We're asking if not in that, then be valid is false. Right, so that is our checking to see, and that is our message if it's false. The exit means we don't have to do an else. It's a very nice tool to use here. Means that this procedure will end. I'm going to run the program and let's see for the errors. Oh, semicolon missing. Don't forget to put semicolons. Even I forget. Oh, we have another one. Hey, I never declared I num. Might be a good idea. Hey, I num. There, declared as a variable. And by the way, these are local variables. Do not use global variable names inside your local variables. Okay, we are referring to S code over here. We're using the global variable here. Okay, and we used S alpha there. That's the global constant. But now we're using SABC. But it's fine. We can use the global variable here, but don't declare S code as a local variable as well. You must not have the same names that are here. Any names must not appear here as well. You can only have totally unique names all the time. Right, where's my other error? Then, be valid, colon equal. I'm glad I'm making these mistakes. And then we have another one. For do. Forgot to put the do at the end. See? For k equals 1 to length of S-plain text, do. And then begin and end. Right, so there is your thing. I'm going to type I like dogs. And I click the button, and there it is. Of course, the S is there now. Right, so what you're going to do now for the rest of your code, you have to, it's going to be this group box 4 here, you've got to put captions on, and you've got to write code. Will be the same as what you did there, but in reverse. Okay, so you're going to do that in reverse. That's your challenge. And you also have to write code for Scramble Alphabet. You also have to make sure that your names of your buttons and your captions are all nice and neat, and that your edits are cleared. So you just go to the text property and empty it. And then there's a reset button, and oh yes, I forgot to mention that. We're going to very quickly do the bitmap buttons at the bottom here. So you go over here to the top and find BitBTN, and you go and click on BitBTN, and you make one over there, get another BitBTN, and click on that and put one there. This BitBTN, you're going to change the kind property, KIND, to retry, and then you're going to go to the caption and call it reset. You just change the retry to reset. You see there's a little and in front there, don't want to leave that there. And you also have to change the name of the bitmap buttons, BitBTN, BMB reset. And then this BitBTN, you've got to have close. It's got to be the kind property called close, KIND. Go to the kind property of the BitBTN. You choose close, BK close, and you also have to give it a name. You don't have to put code in there, but in the reset button, you have to put code in to clear all the edit boxes and the rich edits. And yeah. But for the Scramble Alphabet, that is where you're going to go and clear and refill the memo, and that is the other challenge. So remember all your names and all your comments that have to be put in every single line, like I showed you with the 2 forward slashes. You see 2 forward slashes, and you write your comment every single line to describe everything. In the Scramble Alphabet, what's going to happen is you can decide how you want to work this, but you can have more than one text file. Okay, you'll have code 1 and code 2 and code 3, whatever you want. You can actually, an idea would be to get a random number. You can work this any way you want. And ran, how many text files we have? Random range. Let's say we have 4 text files. Okay. If you can use random range, and you must know how to use random range, you have to include math in the units there. You have to use math in the user section. And random range, if you have 3, say I have 4. So if I have 5 text files, I'll get a random number from 1 to 4. That 5 means you can get a number 1, 2, 3, or 4. And you have to have the 5 there in order to get a random number from 1 to 4. Then we're going to use rran to join it to a string. Okay, because our text file, we're going to use our text file variable. I'm going to call it tfile : text file. Take note, I'm using local variables here. Hey, sline : string. And then over here, we're going to we're gonna build our s text file, s file name. Build a file name using rran. So s file name equals code plus int2 string rran. Join that to a .txt. And then we can go and check to see if not file exists, just like we did before. Check if the text file exists. Always have to do that. If not file exists, and over here we're just going to use s file name in brackets, s file name, like that. Although we do have to insert inverted commas Although, no, we don't have to do that. I'm talking about. Okay, let's just use this file name. Let's see what happens. So we haven't done this for a while. Then we're going to assign file. T file, the text file variable, to S file name, and then we will reset T file. We also need to what's this memo called? Memcode.clear. We need to clear it because we're going to replace it. And we say while not end of file T file do, and then we're going to read the line and add it to memcode. And we will also read line T file into S line, just like we did before, and then we will memcode.lines.add S line, and we're also going to build our S code is going to be rebuilt. S code, remember that global variable up there is going to hold our cipher. S code will be equal to empty string, and we'll just go and join each character from S line. Each character which is stored in S line, and join that to S code. And then we have it. We've got our new cipher. Now, if I had another text file named code, I can go and make a whole lot of text files here. You can go and put some new other text files in here, code 1, code 2, code 3, code 4. You just got to, make new codes just like we did now, like we did before we typed all the codes in, remember? There are other ways to do it, but this is one way. So you can have all your codes in text files, or you can actually be very clever and generate a code in your program. No. So I just want to make sure I have all 4 because we're going to go run this. I know they all do all the same. They're all the same codes because I copied that one file. But let's assume that they're different. Okay, we'll just assume that they're all different. We just want to make sure that the code works. So run the program. Okay. So equals. Right, when I scramble the alphabet, I should get a different code. So actually what I'm going to do is I'm going to change some of these up. I'm just going to delete some lines because I haven't got time. I just want to make sure that we are reading everything. Making sure that it works. Right, that's the one alphabet. Now we're going to scramble, we get another one, and we scramble it again, we get the same one, then we scramble it again. You see I'm getting different alphabets now. It all depends on what the random number is, so that's how you can do it. Right, so what did we do? We used S file name as our string. No, we didn't have to put inverted commas around it. But we built that string up using a random number, so the code was randomly generated each time. Right, so you know what to do. You've got to finish the other part, this group box here, and you go and look at the Word document that shows you over here. You read those instructions, and yeah, have fun.